Section 3.5, Graphing Function Using Compressions and Stretches. In this section, we're going to study vertical compression and vertical stretching. So if you're looking at a function f of x, and you multiply that function with an integer a such that a is greater than 1, that means it's not a fraction. The function is going to stretch vertically. So if you have y equals a f of x, this function is going to stretch vertically. If you multiply the function with a value, that value is greater than 0, it's positive, but it's less than 1, meaning it's a fraction. So you're going to get the function b times f of x, which is a function that is going to shrink vertically. So let's see what's going to happen if we have f of x is equal to square root of x. First, let's graph that function. At 0, the function is equal to 0. At 4, the function is equal to 2. At 9, the function is equal to 3. So here is the graph of f of x, which is the square root of x. Then if you multiply that function with 3, that means this function is going to stretch vertically. Each of these points is going to stretch by a factor of 3. So this point is 4 and 2. 2 times 3 is 6. It's going to become 4 and 6. 0, it's going to remain 0. And then 3, 9 and 3. 3 times 3 is 9. So 9 is going to become 9 and 9. So here is the new function, which is stretched by a factor of 3. This is g of x equals 3 square root of x. And the function is going to shrink vertically if you multiply it with a number that is a fraction, positive fraction. So the function at 0 is 0. And then at 4, it's going to give you 1. At 9 is going to give you 3 over 2. Which is 1.5. So here is the graph of this function, which is h of x equals 1/2 square root of x. So it shrunk. As you can see, the red one is the parent function. It stretches if you multiply it with a factor that is bigger than 1. If a or b, the numbers you multiply the function with are less than 1 but greater than 0, meaning they're positive, the graph of the function shrinks. So that is called the vertical compression and stretch. Let's look at these combination of transformation. Let's see what happened to the functions here. First, let's recognize the parent function. I see that the parent function here is x squared, which is basically the parabola. At 0, the function is 0. At 1, it is 1. At 2, it is 4. At -1, it's 1. At -2, it is 4. So here is the parent function. And I see that the graph of this function, first, it has stretched vertically and flipped over the x-axis. It's reflected across the x-axis because of this negative sign. And the 2 made the graph stretch. And then I will apply the next transformation. So the first transformation I see is flipping and then stretching. So at 0, it is 0. At 1, it's going to give me -2. At -1 is going to give me -2. At 2, it's going to give me -8. At -2 is going to give me -8. So here is the first transformation. This is one of the transformations in the last, which is namely after you multiply the parent function with -2. So that is what's going to happen. Now the other transformations are, I see the graph was shifted to the right 3 units and then shifted up 4 units. So I will do the shifting to the right 3 units. If you shift this point to 3 units to the right, it's going to be 3 and 0. This point right here, if you shift it to the right, which is 1 and -2, if you shift it to the right 3 units, it's going to become 4 and -2. The point -1 and -2, if you shift it to the right 3 units, it's going to become 2 and -2. Similar to this point, 2 and -8, if you shift it to the right 3 units, it's going to become 5 and -8. -2 and -8, if you shift it to the right 3 units, it's going to become 1 and -8. So here is this shift right here. So basically what we did so far, we applied the reflection, and then we moved the function to the right 2 units. So we're here now. The last transformation is moving the function up 4 units, 4 units up. So if this point 0 and 0 moves up 4 units, not 0, 0, this is 3 and 0 moves up 4 units, it's going to become 3 and 4. If this point moves up 4 units, it's going to become 4 and 2. If this point moves up 4 units, it's going to become 2 and 2. If this point moves up 4 units, it's going to become 5 and -4. If this point moves up 4 units, it's going to become 1 and -4. And this will be the final transformation. And this is basically the final version of the function. So the green function, we did the reflection, stretching, moving to the right 3 units, and then moving up 4 units. And that will be the final transformed function. So if I erase all of the previous ones, only the green is going to be representing the current function we're talking about. Let's work on g of x. G of x is the parent function of g of x is the square root of x. I know the square root of x is equal to 0 when x is equal to 0. When x is equal to 4, the square root is 2. When x is equal to 9, the square root is 3. So here is the parent function, g of x. Then this parent function reflected, and it was stretched vertically because we multiplied here with -2. So we will do the reflection and stretching. So it will reflect across the x-axis, and it's going to be stretching. So here is the second version. When x is equal to 0, the function will be 0. When x is equal to 4, the function will be equal to -4. When x is equal to 9, the function will be equal to -6. So here is the reflected function. Basically, what we did here, we multiplied with -2 square root of x, which is just a reflection across the x-axis, and stretching vertically. Now, there is another movement that happened, which is we moved the graph up 4 units, and also moved the graph to the right 1 unit. So I will do one movement at a time. I'll do the next one, which is moving up 4 units. 0 and 0, if you move it up 4 units, it's going to become 0 and 4. 4 and -4, if you move it up 4 units, it's going to become 4 and 0. 9 and -6, if you move it up 4 units, it's going to become 9 and -2. So here is the graph after we moved it up 4 units. So what we did now, we did 4 minus 2 square root of x. Then the last transformation is moving the graph to the right 1 unit. So I will take this red graph and I will move it to the right 1 unit, which will be the green one. If you move this point to the right 1 unit, it's going to become 1 and 4. If you move 4 and 0 to the right 1 unit, it's going to become 5 and 0. If you move 9 and -2 to the right 1 unit, it's going to become 10 and -2. So here is the new graph of the function, approximate graph of the function. Okay, so now we did move it up reflected and stretched the graph and then moved it to the right one unit, which is the green one. That is the last transformation. So the green graph is going to represent the last transformation of the parent function. You will notice that the next page you'll have all of the parent functions. This is just for you to have. If you could remember all of these parent functions, that will be great. And you can practice translating these graphs of functions if you wish. I hope this video helped you. If you have any questions, please let me know.